Here's example 3 with the law of sines. So we want to solve this triangle ABC given an angle A is 61 degrees, side A is 15, and side B is 20. So notice this is an example of an SSA triangle. So we're given two sides and one of the angles that's not in between them. Okay, so if we were to draw a picture of this triangle, we can't really draw an accurate one because we only know one angle and two sides. We can't really draw an accurate picture. But just to make a rough sketch, something like, so here's angle A, so here'd be side A, and then angle B, angle C, so side C, side B. So we're given this angle A, this side A, and this side B. So two sides and an angle, so we're given SSA. So this is the SSA case, which we mentioned a few videos ago. This can lead to the ambiguous case. Okay? So we have to be careful when we have SSA triangles. And actually, not just because of the ambiguous case, but because if we have an SSA triangle, other stuff can go wrong, as we'll see in this example here. So we erased the picture because we can't draw an accurate picture yet. We can't draw an accurate triangle because we don't have enough information. But what we could do is use the law of sines to get angle B. Okay, so we have angle A, we have side A and side B. So if we think about the law of sines, one of the things that it says is sine of big B over little b equals sine of capital A over little a. We have capital A, we have little a, we have little b, so let's use all that to get big B, if we can. So multiply both sides by little b, and we get sine of big B equals little b sine A over little a. Okay. Now let's just plug these into here. So then sine of B equals what? So little b is 20, capital A is 61 degrees, little a is 15. So this is 20 times the sine of 61 degrees, all divided by 15. Okay. So if this is the case, well, first let's see what this equals. So a couple things to point out here. One, before we see what this equals, a couple things to point out. One thing is we're going to have to toss this into our calculator. So if the sine of b, so let's rewrite this here, sine of b equals 20 sine of 61 degrees over 15, then what that tells us is that b is the inverse sine of 20 sine 61 degrees over 15. Okay. Okay, now when we toss it into our calculator, we should toss it in there like this because 20 sine 61 degrees over 15 is going to be an irrational number. Sine of 61 degrees is not a nice number. So we're going to have to toss it into our calculator like this. And the reason is we don't, because if we otherwise put this in our calculator around it and then use it in here, we're going to be using an approximation to get B, and we don't want to do that. So we frequently mention that we don't want to use an approximation to get another value. If we can avoid using an approximation, we should definitely avoid it. And in this case, we can, because we can just toss this directly into the calculator. Now, with that being said, before we do that, we should verify that this is actually a legitimate value. So what does that mean? Well, what that means is, so let's zoom in here, make sure that we're in degree mode. And what we want to do is check, so we're going to check this 20 sine 61 degrees divided by 15. We're going to check that and make sure it's okay. 20 sine 61 degrees divided, let's zoom in a little more on this, divided by 15. So notice that's actually approximately equal to 1.17. Okay, we'll say that's approximately 1.17. Now that's a problem. Why is that a problem? Because we're saying sine of b equals that. Okay, 1.17. So what we're actually saying is sine of big B is approximately 1.17. But can that ever happen? No, it can never happen because for the sine function in general, it has to be between -1 and 1. So there's no possible angle B that's going to give us sine of B equals, or even approximately equals 1.17. So this is just not going to happen. It can't happen. It won't happen. So this actually is no solution. So if we try to toss this into our calculator, what would happen? So what would happen if we try to say inverse sine of all that mess there? And again, if we were to toss it into our calculator, we don't want to use the approximation. Again, just avoid the approximation, avoid it. So let's say we just want to take the inverse sine of this. What would happen? it's undefined, okay? So if you forget to verify this beforehand, if you forget that step to verify that, make sure this is less than 1, then when you try to do this anyway, you're going to get undefined. I think the TI-83 has a similar exception or error message. But anyway, it's just not going to work. You're not going to get a number back. It's going to say undefined or something of the sort. So since this expression is approximately 1.17, we cannot take the inverse sign of it because you can't take the inverse sign of things larger than 1. So there is no such B, which means no triangle. No triangle ABC. So there's really no solution here, and actually there is no such triangle that has these given measurements here. So angle A is 61 degrees, side A is 15, side B is 20. There is no such triangle that has those measurements. If we were to try to draw one, see, this is why we didn't want to draw one too soon. If we were to try to draw that, it would be something kind of sort of like this. So here, this would be C, this would be B, this would be A, which we were given as 61 degrees. And then here's 15. This is side little a is 15. This little b is 20, and this will be side little c over here. So notice this, the problem is that this side is too short. Okay, so that's sort of what's happening kind of behind the scenes. When something like this happens, this is really what it means. So the angle B we see does not exist. There's no such B, and the reason is that this side is not complete here, so there's no real angle B. So if we try to draw the triangle, this is what it looks like, just as a side note, FYI. So it's just not a triangle. It's not filled in over here. This side is not complete. So no such triangle with these measurements. Impossible, cannot be. So the answer is just no solution, no triangle ABC. And that's example 3 with the law of sines, and it just illustrates some of the problems we could have if we have an SSA triangle. So remember, this was an SSA because we were given side angle, so SSA. But in that case, it could be the case that the triangle just doesn't exist. And that's what happened here in example 3.